In our experiment number 2, we are going to modify our neural network structure, trying to obtain a better generalization. And we will do that by adding the activation function. So if we look at the code, we are uncommenting the leaky relu, and we are also uncommenting here so our output now is first goes to the first layer, which is the linear layer, and then we apply an activation function, which is the leaky relu. We will not make changes here, so we are still using the stochastic gradient descent optimizer, and here also we are not changing anything. We just run our model and we see that we have different results. So now the loss for our training set is 1.8 in the magnitude order of magnitude 10 to the power of -5, but we have the validation loss is 0.144. When we compare the previous experiment, it was 0.5. So we already have some good reduction on the validation set, meaning that our model is generalizing better. So here we get a loss. Our training set is a very small value. For the validation set, we get 0.441, so it's much better than before. So using this activation function helped for better generalization. In our final experiment, we are going to change the activation function. We are going to use the relu, and we will see the effect of vanishing gradients on the optimization. So this function has a constant 0 for negative values and hence a vanishing gradient for negative values. So what we do is now we are not going to use the leaky relu, we are going to use the relu, and here we didn't change in our forward part. We're still using the same optimizer, no changes here, and we see that we run our experiment, but we see that the loss gets stuck and is not changing after some time. And here we see that even in the training set, the loss is 0.166, so the optimizer gets stuck at a loss value of 0.166 to retrain, and this is caused by the vanishing gradient of the relu function in the negative input range. So with these 3 experiments, we've seen the effects when we are not using activation functions, when we are using an activation function, and we need to be aware of the characteristics of our data, the characteristics of our network architecture, and the characteristics of our optimizers. So there are thousands of parameters we can change, and we need to have a certain intuition on how to fine-tune our model to achieve the results we want.